What's up gamers, it's your boy, back with another video, and I know exactly what you're thinking right now. What's the fastest someone can drink a 32-ounce bottle of harmless coconut water? Well, after watching the video, we now know that the answer is 13 seconds. You may be thinking, huh, how do you do it? Well, while I can't reveal how Badlands does it, because that wouldn't be very cash money of me, I can explain how the process occurs. So buckle up, because you're about to learn you some chemistry. Let's start from the beginning. First, the coconut water starts in the esophagus, then travels down to the stomach. But for this informational segment of entertainment, we're only going to focus on the skeletal muscle found in the esophagus. So let's begin. First, the nerve impulses goes into the neuromuscular junction, which is the point where the axons of the nerve meet with the muscle cell. After the nerve impulse, acetylcholine is released from the axon to the receptors on the sarcolemma. The binding of the acetylcholine to the receptors causes the depolarization of the sarcolemma, which then opens the ion channels, allowing sodium to enter the muscle cells. Once the sodium is in the cell, it diffuses and depolarization occurs. This depolarization causes a wave of action potential to cross the sarcolemma. An action potential is defined as the change in electrical potential associated with the passage of an impulse along the membrane of a muscle cell or nerve cell. However, for this video, I'm going to focus solely on the muscle cell part. First, the stimulus causes the sodium to leave the cell via the sodium channels, causing the microvoltage in the cell to change from a resting negative 70 microvolts to at least negative 55 microvolts. If the stimulus does not cause the microvoltage to reach at least negative 55 microvolts, then the contraction will not occur and the charge will return to its resting energy of negative 70 microvolts. However, if the stimulus causes it to pass negative 55 microvolts, then the contraction will occur, causing the sodium channels to open, allowing the sodium ions to rush out of the cells, which causes the depolarization. The next step after the cell energy level reaches about 30 microvolts is the sodium channels closing and the potassium channels opening, which causes the potassium to exit the cell and the sodium to enter. This causes the repolarization of the cell. However, the cell then goes through hyperpolarization when there's too much sodium and not enough potassium, which then lowers the energy level of the cell to about negative 90 microvolts. And once this happens, both the sodium and potassium channels close. The closing of both the channels causes the energy levels to return to its resting rate of negative 70 microvolts. Now that you understand what action potential is, we can get back to our regularly scheduled program. This action potential then travels down the sarcolemma and down the T-tubules. This causes the sarcoplasmic reticulum to release calcium. While the calcium levels are rising, the calcium ions bind with the troponin, which removes the tropomyosin from blocking the actin binding sites. Myosin then binds with the actin and forms cross bridges which start the contraction process. Then, to start the contraction, ATP binds to the myosin. The ATP is then broken down into ADP and PI, which then allows the myosin heads to attach to the actin filaments and pull it forward. Once it's pulled forward, the myosin releases ADP and PI, causing it to return to its low energy position. The myosin heads are now in their starting positions and are ready to receive more ATP and repeat the process. This process occurs for every muscular contraction. Now you may have forgotten what the point of this video was. It was in order to further your understanding of how much of an absolute unit Badlands Chugs is. And to prove how godly his feats are, I will now attempt to drink 32 ounces of harmless coconut water in under 13 seconds.
What's up gamers? I couldn't find 32 ounces of harmless coconut water, so I'm just gonna do these two 18 ounces. So yeah, let's see. Hopefully I'm just gonna open one so that I can this is such a dumb idea. I'm sorry, Mr. Stewart. Just gonna leave one open so that I can get to it faster. Okay, so the cap there. I'm just gonna leave all this in raw so you can really see the process that occurred. I'll put the timer up on the screen now. This is such a dumb idea. One down. Oh, I think I'm about to throw up. I'm back. I definitely did just throw up. That's all.